Same idea from algebra 1 and algebra 2. So let me check attendance one more time because of the tardy students. Okay, Olivia, not here. Everybody here, right? So let's compare to the ellipse. Ellipse is the one of the conic sections, and ellipse has property like this. You have 2 points. It's called focus, okay? So we have 2, so we say foci, okay? It's not foci, foci, foci. We say focus, but when we say plural, it's foci. So we have foci here, and from any point on ellipse to the focus, another one, and the sum is equidistant. So we watch the video and we have thumbtacks and string, and we can draw an ellipse by using that same length of the distance of the string. So you can move it around and we can find this nice locus. That trace of the points is called a ellipse. Ellipse. Okay. And this is not ellipsis. Okay, ellipsis means dot dot dot. Okay, so that's ellipsis. This is on curve. A curve is called an ellipse. A plural noun is same as ellipsis, ellipsis. After all, it looks same, isn't it? Okay, so we talk about ellipse last time, and it is very similar, okay? An equation of the ellipse was like this: x squared, y squared, in the denominator a squared, b squared. On the right hand side we had 1. So compared to this standard form of the equation of an ellipse, we can say hyperbola is like this: x squared of a squared, y squared over b squared equals to 1. Instead of sum, we will find the difference, okay? So it's kind of inverted shape of this kind of drawing. It is an oval shape here, right? And we will think about different way of going backwards, okay? So definition of the hyperbola is the trace of the points, locus of points whose difference in distance from 2 focal points or side is constant. So this is the distance that is measured, 10.25. And this is the distance we measure, and that's 2.25. The difference is 8, right? And the other one, we move the position, P, point P moved up, so it gets longer. And this one is also getting longer because the point is far away from 2 focal points. But the distance between 2 distances from the focal points, that is still same number, 8. So those points, collect all those points like that, that is forming a blue curve here. That's called the hyperbola. Hyperbola is the locus of points whose difference in distance from 2 focal points is constant. Okay, so that is how we identify in ellipse and hyperbola. Hyperbola difference, ellipse sum. So that was about the distance. And we have vocabulary words for those parts, and there is point here, and this axis passing through those points on the curve is called transversal axis. Transverse axis, okay? Transverse axis, and the other is called co-conjugate axis. So it's paired, okay? So transverse means points are on the axis. And as you see, the graph keep goes in both the directions, and there are asymptotes. So this line formed along this side and the other side of the hyperbola is an asymptote. Likely, the other one is also called an asymptote. Okay, so consider those, and we can think about this position, vertex, and we can consider this position from the equation, and there will be co-vertex. But we don't make an ellipse, okay? Instead, we draw a box around them. Corner to corner, diagonal, you connect them, and that is going to be an asymptotes, slant asymptotes of hyperbola. So those are the key things. So to draw an hyperbola, I need to use these points and then draw a box around it and then draw asymptotes first, and then you can draw hyperbola in both ways, okay? Hyperbola has two focus points, two foci, okay? So that's different from parabola. Parabola has only one focus point, but hyperbola has both of them. So we can consider distance from the focal point to the position and that position to another focal point, and then we will calculate the distance difference. So that difference is constant. That's called the hyperbola. So let's see. So knowing that x-axis goes with numbers on the x-axis, okay? Y squared below, you have a number that goes with co-vertex, okay? So let's figure it out that first, and then let's find the equation of this, all right? So what is going to be my A and B? Let's write the format first, okay? This is going to be the format. And tell me what number is with y values. Y values goes with 2 and -2, right? Square it, what do we get? 4. So that is the number with y. All right, and this is transverse axis because the vertex is passing through that axis. What number goes with the x squared? That's right, that will be from -3 and 3, which makes square the number, that is 9. So that is the equation of a hyperbola. Make sense? Next one, same way, x squared plus y squared. Okay, it's a fraction, and let's find the number. X-axis goes with these numbers, so that goes with 9. And here, number is 2 and -2, so that will be 4. Make sense? Is the same? Is the same looking? Oh. It should not be same, right? So what is the miss here? So let's go to the formula paper and let's find the thing. Which one is forming this way? We can say this is called the vertical transverse axis, okay? Vertical transverse axis. Okay, this one is horizontal transverse axis. It should not be same, right? I need to change something. So let's go back and let's figure it out. What is the difference? Did I choose the numbers right? Yes, because we use the same box. We got the same equation, right? Okay, so let's go to the formula paper over here. It is on the first page also. And ellipse, we switch A and B's here like that. If we have a vertical major axis, horizontal major axis, this one look like that, and the other one look like this, right? And hyperbola, we have vertical transverse axis, that means hyperbola look like this, along this vertical axis, okay? Horizontal axis look like that, horizontal transverse axis, and hyperbola looks like this along that axis, right? So, and K and H, those are for H, comma K, X and Y, okay? So which one is the normal way of we usually write? X first, right? So this is for horizontal transverse axis. So if parabola goes like that, we write equation like that, okay? If it is flipped around this way, rotation, okay, and equation goes like this. The formatting is exactly similar way, but I need to consider y first and then x after that, okay? So this is y-axis, right? And then y first. This is x-axis looking, and I go with x-axis first, okay? So let's back to the page. Where was it? Over here, ellipse. No, hyperbola here, okay? And back to that. And which one is first? This one, x-axis first, right? Oops. By the way, why you didn't tell me? It should be negative, right? And what do I do? Okay, let's switch this order. So vertical transverse axis, and then I need to go with y squared. What was the number with y? 4, that's right. And minus x squared and 9. So that is y-axis is the vertical transverse axis. Okay, the equation look like that. And this is the regular way of looking, okay? Okay. Now number 3 look like number 2, horizontal transverse axis, right? However, it is moved. So I need to figure it out what is the transformation from the center 0, 0 to this new center 1 and 3, right? So I'm going to use a vertex. I'm going to use vector notation for the translation, okay? So to the right, 1 unit, up 3 units. So let's write the equation just like number 2, x squared minus y squared. Okay, what would be the number with the x? So from that position, we count 1, 2. So that will be 2 to the second power 4. Y value 1 unit, so squared 1, and then we can say 1 to the second power, right? Can I omit writing 1 over 1? And we can do that and equate it with 1. So now let's apply the translation rule, okay? To the right 1, so x minus 1, up 3, y minus 3. So this is the equation of a parabola. If you want to write 1, that's fine. You can write over 1. Does it make sense? Any questions? All right, now let's do a little bit of algebra 1 to answer next question. Okay, can we find the equation of asymptotes? Yes, so we will start rise over run from here to here, okay? Here to here, here to here, it doesn't matter. So let me use first the quadrant. What is the position getting here from this origin? Rise over run. 2 up, 3 to the right, right? So y equals rise, 2 up, 3 to the right with x. So that will be 2/3 times x, origin 0, 0, right? Okay. The other one will be negative. So we have 2 equation makes the asymptote. One is positive 2/3 x, and the other is negative 2/3 x. Make sense? Okay. What are the vertices? Vertices are, this is the vertex, right? Vertices are there. And this is the co-vertex, right? So you can name those as a point. The vertex. We have 2 vertices at 0, 2 and 0, -2. Co-vertices. Co-vertex is at 3, 0 and -3, 0. So you can answer all of them like that, okay? How about number 3, asymptotes? It's not passing through the origin, right? So I need to consider finding equation of the line. What is the slope? Rise over run. So slope is rise 1 to the right, 2, so 1/2, right? And the other one has going down, so slope is negative 1/2, right? So you need to use one of the points, which is 1, 3 as a point, and then you need to do algebra 1 here to find the equation of the line. So y equals mx plus b, and one of the points is at 1, 3, so 1 and 3 will be plugged in, and we are using slope half to find b. What is b? Let's subtract 0.5 from 3, which is 2.5. Okay, so one of the asymptote is 1/2 times x plus 2.5. That is one positive equation of the line here, okay? And the other one, you can do the same way. On the y equals mx plus b form, you plug this position, 1 and 3, and this negative slope. So let's plug in and let's calculate it. So plus b, so b will be add 0.5, so that will be 3.5, right? So the other equation is with the negative slope plus 3.5 here. So we have two asymptotes. Because of the translation, and my equation gets a little bit complicated, okay? Otherwise, it is same from the same way, okay? Either 1 or 2, because we have a different slopes, we have to consider two equations together. Any questions so far? Next question, can we graph it? Yeah, right, we can graph it. So before we start graphing, let's think about which form we have. This is starting with the x squared. It look like x, isn't it? Okay, x looking, and you start with x squared, okay? And the other one, you start with y squared. That's easy to remember, right? Okay, so next one. The hyperbola of this look like this way, right? Y-axis is the the transverse axis. This one look like that. Okay, this one also look like this, right? Yeah, that's right. So you can find A, B. What is A? Consider the number with x, okay? So you're using 3 and negative 3, right? 3 and negative 3, and 1 and 1. So don't draw an ellipse, okay? Draw a box around them. So draw a box around the co-vertex and vertex, like that. And then equation of the asymptote, okay? What would be the equation of end behavior? So that is called asymptote. So let's try to connect those corner to corner, okay? Corner to corner, that is the asymptote. So they didn't ask us to write the equation of the asymptote, so you don't need to worry about it. Just connect the diagonals and expand, and you're going to have a proper, excuse me, hyperbola. So hyperbola look like that. So it touches this position, and okay, other position, that's fine. You draw a rough drawing, that is good enough. So this position and shape look like that because we start with y-axis, y squared, okay? So this is the hyperbola from this equation. Next one, you think the same way, and then you have to do translation, okay? So move to the left 2 units and move up 1 unit. Or you can just start from there, that's fine. Just move the position. So negative 2 and 1 over here, and then that's going to be the center point of the box, okay? All right, so let's put a box. X number is 4, Y number is 4, so we go 2 to the left, 2 to the right, 2 above, 2 down. So draw a square this time, right? Okay. And then let's construct asymptotes. Okay, this is asymptote, and the other way around, asymptotes. Okay, and now let's complete the shape. So the shape is starting with x squared, look like that. So here, this is the position. Here, this is the position. So follow the asymptotes at the end of the hyperbola, pass through the vertex, and that is the graph of hyperbola with this equation. How do you feel? It's all right? Okay, and now we leave the